Alright, Algebra 1, Lesson 61. This one is on subsets and then subsets of a set of real numbers. All that to say, just write these down, okay, for just a minute. B, now this isn't, B is always this. They're just showing you that B, and then they have this little set like that, okay? And then A, and they have a set like this. Okay? Now, these little brackets that I've got basically represent what's inside. This 1, 2, and 3 represents A. This 1 and 2 represents B. Okay? That's all that's showing you. Now, it's asking me B, and then it's got this little swirly, almost looks like a C sideways squish. Okay? And that C sideways squish would almost be like an equal sign or something like that. But basically what this means is a subset of. That little signal means subset of, which means a part of. Okay? So go and write down that that's what it means so you'll know. That this means that's a part of. So what we're saying is B a part of A? Or is B a subset of A? Well, B has 1 and 2, so could B be a part of A? Yes, because it has a 1 and a 2, but it also has a 3. Okay? So this is true. Okay? But if I turned it around and said is A a subset of B? No, it's not, because it doesn't include them all. So it has to have all to be included into that. So you would say no. See how I did that?
Yep.
You draw a line through it.
Yep.
That is not a subset. Okay? Now sometimes C, let me just show you C real quick. 3, 2, 1. C and A are the same thing. This is just written in a different form, and so it's called improper form. Okay? No big deal. That's just, I'm just showing you just in case they ask you different things. Okay? Anytime you see something like this, and it's empty, you would just say it's an empty set. Okay? I don't know when you would see that, but there you go. Okay? Let's see. This set is called an empty set, or a null set can be designated to show. So I don't see any reason why you would say that, but anyway. Okay, now let's do this next problem. D, and then they tell me that D equals, and then they've got 0, 1, and 2. Alright? And then they tell me E. Now this is going to look different, just a tad. It's going to have 1, 2, 3, and then it's going dot, dot, dot. What does that mean, do you think?
4, 5, 6.
It's going to keep going on forever, okay? So that's what those dots are to express. And then there's a G. I'm not sure why they didn't do F, but it doesn't matter, okay? And so then they go 1, 3, and 5, and that's it, okay? So now, they want to know which ones are true and which ones are false. So, E, and then it's got this little subset. E is a subset of G. B says G is a subset of E. And C says that D is a subset of E. Okay, can you see all those?
Yes.
Alright, so let's tell if it's true or false. Is E a subset of G?
No.
E a subset of G? No. Because of the 2. Okay? So because E has a 2, it's not a subset of G. So we would say false. Okay? So I'm going to put an F on top of that one. Done. Okay? B. B says, oh, I can see it here. G is a subset of E.
Yes. 1,
3, and 5. Will this have 1, 3, and 5? Yes, it will. So this one is true. Okay? And then C. C says D is a subset of E. D, subset of E.
No.
No, because it has that 0. False.
Yep.
Okay, so you just put false, true, false on those, okay? Just to let you know. Okay, now we're going to learn the second part of this lesson, which are subsets of the set of real numbers. Blah, 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 blah. Okay, so I want you to draw this chart on your page. Okay? So I'm going to draw small square at the bottom, about like that. And I'm going to show you natural numbers. Okay? And this would be 1, 2, 3, 4, 5, dot, dot, dot. Keeps going on and on and on. Natural, it's a natural, you talk about it as natural. Okay, so you start with 1, 2, 3, 4, 5. Those are natural numbers.
Yeah.
Okay, now, within natural numbers, we're going to have a bigger set, and that is whole numbers. Now, there are fractions, and then there are whole numbers, and this makes a mixed number. Okay, but when we're talking about whole numbers, it would just be this part, not the fraction part, but just the whole. So, whole numbers include 0, 1, 2, 3, 4, 5, and so forth. On and on and on and on and on. But it just does not include fractions. Okay, you see that?
Yep.
Alright, so, are natural numbers a subset of whole numbers?
Yes.
Yes. But are whole numbers a subset of natural numbers?
No.
No. So, that's why I have natural inside of whole to show that natural is a subset of whole. Okay, now, you ready? I'm going to draw an even bigger one. And this one is called integers. We actually did this in last year, one of the lessons. I think it was at the very end, the very last lesson. Okay, integers are numbers that you would see on a number line. For example, 0, 1, 2, 3, dot, 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 dot. It keeps going on forever. And -1, -2, -3. Okay? Those are integers. Okay? Are natural numbers a subset of integers?
Yes.
Yes. Are whole numbers a subset of integers? Yes. Natural and whole are all parts of integers.
Yes.
But are integers a part of whole numbers?
No.
No, because it has negative numbers too. Okay? Alright, again, draw another. This is our last step of this portion. So go on and draw another, something like that. And this one is called rational numbers. Rational. Okay? And rational numbers are fractions, decimal numbers, etc. So, for example, a half, 0.3, what else did they give? -2/3. So it includes positive and negatives, but it also includes fractions and decimal numbers.
Yeah.
Okay? So, we would say naturals are a part of rational, whole numbers are a part of rational, integers are a part of rational, but rational are not a subset.
Yes.
Okay, you got it?
Yep.
Alright, now, we're going to draw our own side, because this is in a whole different category. Irrational numbers. Now, the best example of irrational numbers would be pi. Okay?
Yeah.
Because why? Because pi never ends. It literally keeps on going for the rest of our lives. So 3.145916943. It keeps going on and keeps going on. So it's considered irrational because you can't come to an end of it.
Yep.
Half comes to an end. 0.5. It ends after that. See what I'm saying? 0.3. It has an ending. 2/3. If we divided that, it would come to an ending. Okay? But irrational numbers are those that do not come to an ending. So, pi would be an example of an irrational number. Square root of 5, what number 3 times to be the square root of 5 would be an irrational number. We can't figure it out. It's not just 2.2. It's 2.2, 5, 4, 3, 8, stuff like that. So just letting you know that that's what that means. Here's another example. Negative square root of 2. That's another example of irrational numbers, okay? Even square root of 2, for that matter, is an irrational number, meaning we can't figure out the answer to that. And when we get close, round it, but we can't come up with exactly. That's irrational. Now, if you can box this whole shebang in, you have what you call real numbers. So, real numbers. Is it a real number? All of these are numbers. All of them are real. So it's considered a real number. So natural are a subset of real. Whole are a subset. This is a subset. This subset. This subset. Okay? All right. You get it?
Yep.
So that's how that works, just to show you. Alright, I believe. Okay, so now let's do some of the problems you're going to see in your lesson practices. Now that you've seen that, let's do some of the stuff you'll see. So, they're asking me, they've got this half, and then they've got this C with a line. It almost looks like an E. And basically what it's asking is, what is half a part of?
A whole.
No, I'm sorry. Which of those sets that I drew here,
Yeah.
rational, irrational, real, whole, or all those, what is a half, what is it a part of? It's a integer,
It's
right?
irrational. Yeah.
Is it integers? No, it wasn't integer, sorry, I
It's
said that
rational.
wrong. It's rational, that's what I meant to say. I was thinking it in my head and I wrote the wrong thing. Okay, it's rational, and what else is it? Anything else?
It's part of the.
It's
real
always
numbers.
real. Okay, always. Alright, now let's try another one. What is 5?
Natural.
Natural.
Whole.
Anything else? Whole.
Integers.
Integer.
Real.
And real. Yep, that's it. Is it rational? I guess it could be rational because, because if we divided something divided by something, it could be, so 10 divided by 2 it's a rational.
Yep.
Okay, you got it?
Mm-hmm.
Alright, so now let's do 3 square root of 2. And what is this? This would be one of those irrationals, yep. So it's this irrational and real. Okay? Got it? That's what you would do. So whenever it asks you this, it's saying what is it a part of.
Yeah.
Okay? When it has that little E signal.
Yeah.
Okay? Now, help me out with this. Okay, they're going to like group this together and they're going to say reals in integers. Now, what this is saying is, let's say we had integer numbers here and we had real numbers here. We're asking, is reals a subset of integers?
No.
No, but integers are a subset of reals because everything is reals.
Yes.
So, reals, it includes irrational, rational, all of them, so they're not always integers.
Yes.
So this is false. This is not true.
Yes.
You get that? Okay, so you would just put false. All right, let's try the next one. Irrationals, and I'm just going to use those 2 letters for irrational. And then they're asking me, is it a subset of real?
Yes.
Yes, true. Got it?
Yep.
All right, let's try this one. Irrationals, don't worry about that, it's okay. It'll quit. Irrationals, are they a part of rationals? Irrationals a part of rationals.
Mm-hmm.
Irrationals are like pi and all that.
No.
So no. Rationals could be a part of irrationals, but irrationals cannot be a part of it. So this is false. Got it?
Yep.
All right, let's try another one. Whole, I'm just going to put WH. Whole numbers are a subset of natural. Is that true? Well, whole numbers include 1, 2, 0, 1, and 2, and naturals just do 1, 2, 3 and keeps going.
No.
Okay, so whole numbers are not, because 0 will not ever go into that. So, is whole numbers a part of natural? No, because it has the 0. All right, and last one that they asked. Okay, they said integers real.
Yes.
Yes, because all of them are always a part of real. It is a subset of real. Okay, you understand?
Yep.
That's lesson 61.